Hello guys, today let's discuss the concept of mapper in Java 8. So it was introduced in Java 8 actually. So what is mapper, right? So this is one of the method in the stream in Java 8. So what exactly is it, and when and where do we use it, right? So like it says mapper, it is going to map, taking some input and spitting out the transformed element. Okay, so basically it is mapping uh, one element, so it could be anything, right? It is mapping that to something else, and then it is returning that transformed or mapped result as an output, right? So usually where do we use it? So it is mostly used on the list of stuff where you have a data structure that could be iterable, right? Which could be like you could be able to iterate through the data structure. That kind of data structure you can apply map. So basically you can call map on that stream of elements and then apply function on every element, transform every element, and then return the output. So that is the use case, right? So quickly let's dive into simple demo. So you will get the idea, right? So here I have simple Java main class, right? Let's define some data structure here, which could be a list of integers, right? Let's start with a simple concept, right? And list equal to arrays as list. Let's take a list of integers 1 2 3 4 5, right? So list is iterable, right? Now if I print out this list, what it's going to print out, let's quickly run this. So it printed out the array of elements, right? Let's say if I want to apply some function on every element, so I want to transform this element before I take this as an output, right? For example, what I'm saying is on every element I want to do some operation, and then I want to return the result of all the elements, the transformed results, right? So for example, in this case I would like to add uh, 2. I would like to add number 2 to every element of this list. So what will it turn out? It should turn out to be like 3 4, right? And then 5. So on every element, once you do this additional operation, that's how it will turn out. So usually how do you do that in imperative programming? You will write for loop, and then inside the loop you'll get the list of every element, and then you'll add that and you'll put that back to the another list, which is kind of verbose, right? For that you'll have to define another list, empty list, and then you'll have to call dot add operation. So it is bunch of lines of code. So that is imperative still, there's nothing wrong with it, right? You have been doing that for last many years. Since Java 8, after introducing this functional concept, we can utilize the map when you want to transform the elements. So there are a lot of other functions which were introduced in Java 8, which will enable you to write functional programming. But today we're just focusing on just the map. Okay. So utilizing map. So like I mentioned, map is a method on the stream, right? Which is coming from util.stream, right? This stream class. So let's try that map here, list dot stream, right? What the stream does, stream returns the sequence of elements from this list, and then on that sequence you're going to call map. See, this is a map method on the stream. And what is map taking? Map taking function as an argument. So you can supply a function which is a lambda here, right? If you don't know what is lambda, refer to my previous video. You'll get the idea or the concept of lambda. So it will take the lambda function, which is nothing but a closure, right? And what we're saying is, hey, apply this function on every element that you get, and then return the transformed element, right? What will it look like? It's going to take function as an argument. I supplied function, and this is the syntax. So this is the argument, and then this is the body of that function. Okay, so what is this element? This is the element that is coming from the stream. So on every element it's going to call this function. So what we need to do on that element, we want to add 2, number 2. So n plus 2. So once we add it, we need to return that. This function has to return the result, the computed result. So we're gonna return that, right? Good. So once we do that, this is one way of writing, but since we have only one line of code, what we can do is we can directly let's put that here. We can directly write here n plus 2. A simple lambda, right? So once we do map, it's going to apply this function on every element and then return that. So we want to get the transformed elements, all the elements, right? So what we need to do is basically this map returns the stream again, right? On that stream you need to collect all the elements from the stream. So you'll call collect. What collect takes? It takes collectors. You're saying, so what you're saying is to collect, hey, give me all the list, give all the output as a list. So you'll use collectors here to list, and that's it. So usually when we do map on stream, you will do final statement will be collect, and you're saying give me all the elements as a list again. So since it is all one expression, we're going to assign that to a variable. What are you going to expect? You're going to expect the same list of integers, but this would be transformed elements, right? You can say this is before transform, and then this is after transform, right? So let's run this. Let's clear this to make it obvious. See, the first one is before transforming the elements, and after that is after transforming. So what it is doing on every element, whatever the function that you supplied, it is applying that operation on every element, and it's returning here, and eventually you're collecting it, right? This is a simple way of writing functional programming. And there is other, maybe we can quickly try. For example, if I want to filter out some of the elements, right? So I want to filter also same syntax. It takes a function, and that function should return whether true or false, right? If it returns true, then it is going to it wouldn't filter that element, right? It will let it flow through the rest of the chain. So for example here, let's say if I'm going to return false for every element, when you collect, you will get empty, nothing will be there, right? You want to see that? So the second output here should be empty, because we're filtering out everything. See, empty. And if you return true, then you'll get all the elements, right? So the point is, in the filter function, the function that you're supplying, it can do whatever the computation, and eventually it should return whether true or false, whether you want to return that element or not. So in this case, let's say I want to return only if the number is even, right? I can say percentage 2 equal to 0. If this condition is satisfied, then only return that element to the next chain, right, which is the dot collect here. So now you will see only the even numbers in the result. Let's run that. See, only even numbers, 4 and 6. So this is another function in the stream, which is going to be used as a functional programming. Imagine if you want to write this same logic in the imperative style, you would have written some for loops and then bunch of if conditions and defining new data structures, and you want to do operations on that. It is going to be a big number of lines. So that is the advantage of functional programming, that you could be concise and you can write in the form of pure functions which cannot be tampered by side effects, right? Otherwise you will run into those you will define variables and then you'll modify those variables in the program, rest of the program, right? When you allow those kind of patterns, then there is a chance that you would introduce a lot of bugs. So in the functional programming, there is no way that it can be mutated by mistake, or so you can write purely immutable programs with immutable data structures, and the way you do operations, it's all going to be clean and it's more expressive, right? So yeah, so that's what is called map and filter. Any functional programming, this is the kind of syntax you would see. The methods would take functions, and like I mentioned in the earlier videos, like it's all about writing programs by composing functions, which is like you can pass functions to a function, you can pass functions as an arguments, a function can return another function, right? So it's all about functions. Anyways, that's all for today. Next video we'll catch up with another beautiful concept. All right, see you guys. Thank you.